Hello, everyone. Welcome to physics. My name is Matt Treaster, and I'll be your instructor this term. And this is going to be a welcome message and kind of overview of the course. One thing I really want to do in this course is make a good of a connection as I can to everyone. I know a video component isn't always necessarily part of the courses. Here it's new, but it's definitely going to be part of this course. So this is going to be a welcome message, and I'll get into the other video content as I go. But I do want to make a strongest connection as I can with all the students and know that I'm there for support, and I think that's going to be important. So as far as physics go, I'm really excited about this course. Physics is a subject that I love, and I love teaching it. And I find that students find it fun too. I know that a lot of people have gotten interested in physics or astrophysics or astronomy or cosmology or whatever, one way or another. A lot of that is kind of the popular media that's kind of been out. Actually, for a while, I'm thinking of like Carl Sagan, Stephen Hawking, Neil deGrasse Tyson, kind of on and on for more the general public. And I find that's really great for piquing everyone's interest because kind of starting at the basics of physics isn't always the most exciting. We're not talking about galaxies and astrophysics and stuff like that, and that can be really interesting. But it really is the basics for that kind of stuff and going through really learning the basic laws that underlie all that type of stuff. So I really want to encourage that type of interest. But also I know we have a lot of environmental science majors and that type of stuff. And across the spectrum also computer science and other ones. But there's also a lot of great examples in earth science, environmental science, geology, that type of thing. Also energy and transportation and infrastructure and stuff we go through every day. So I really want to, whatever kind of subject that you're interested in that relates to physics, I really want to try to bring that into the course as much as we can. And the discussion board will be a big part of that. So as far as the course goes, it looks like about half of you have logged in already, which is great. The course doesn't officially start tomorrow, but getting a head start is always good, and especially for this course. I did want to get this message out a couple of days ago, but I was sick, but still have time since the course doesn't start till tomorrow. And like I said, this is kind of going to go over overview of all the whole course. One thing, I've taught this course quite a few times by now, and one thing I find that's kind of lacking with the course design is just an explanation of how the course works. I think some of the more straightforward components are explained fairly well, but I think as some of the other ones are not specifically the project that we're going to be working on. So I'm really going to stress that. One thing is I want to make sure you read the announcements. Everyone needs to read the announcements, but I'm also going to do this video content. And I don't expect information to be in the videos that isn't in the announcements, but I still want you to read the announcements even if you watch the videos. Okay, so yeah, the first thing I just wanted to mention is physics courses kind of have a reputation for being difficult. I don't really see that in this course. I would say the most difficult thing I think is probably, other than understanding the concepts, and I'll be there to help you with that. And you also have the ebook and other online resources. But I would say that the biggest thing is just the amount of time that it will take to solve the problems. We're going to have problem sets every week for the first 6 weeks out of the 8 weeks. And towards the beginning, they can take some time. I find, I don't know if it's the average, but a decent amount of the students, it'll take 20 to 30 hours for a lot of the problem sets, give or take. Some students, especially if you've taken physics before, which I find, or you're just good at it. Sometimes it can go faster than that. But I would say one real important thing is to get started on the problems as soon as you can in the week. And another reason for that is if you start on the problems and you know what they are, you try to work on them, even though you haven't solved them yet, you'll have that knowledge of what they are in your head, and you'll be able to think about them sometimes. One good advice that a professor had to me is that the way you do physics is you have to be thinking about it a lot all the time, eating your cereal in the morning. And that really is kind of the way that you are able to solve difficult problems. It's usually pretty rare that you can solve them on the first go at them. And so that's why it's really important to get started early, because then you'll have that time during the week to kind of think about them. Yeah, so the other two components are the discussion board, which is pretty standard for most of the courses. So I won't go over that a whole lot here. And then the other component is the what's called the final project, or the project that you'll be working on throughout the course. And that's different than most physics courses. So there's no tests in this course, which I think will make a lot of people happy. I know a lot of students will have test anxiety, especially when it comes to physics, and so that's not a component. But the other side is we'll be writing papers, which is not something that's usually part of a physics course, but I think is actually really great, even just for your career. I know a lot of students already have jobs working in their chosen field or working on their careers. Maybe they want to switch careers. Maybe they started and didn't necessarily have the education. I've actually been in that situation too. And you'll find that in the real world, it's not about taking tests, but a lot of times it's about writing reports or memos or communication of the scientific knowledge or data like that. So I think that's a really good component. But it's also, it has its own difficulties and does take a decent amount of time. So that's the main thing that I'm going to try to keep explaining and do the best job of explaining how that project works, because I think part of the course design is a little bit lacking on explaining how the whole final project works. Now it's there. I just think that students need more explanation, and I'll be there to explain that. So this video will be a little bit long because I'm going to cover everything. But so for the problem sets, I already talked about that some, but what you're really going to need to do, the first thing that you need to do is set up your WebAssign account. And that's going to be really important. And I think only 3 students out of almost 30 have done that so far. So that's going to be real important. If you're watch this on Sunday, I would say that's the first, for everyone, this is the first thing that you need to do, and as soon as possible. And there's not very few students really have trouble setting up their WebAssign account, but every term there's a few for whatever reason, and usually it's not their fault. That there might be some glitch that comes up in it. So that's the other reason to make sure you get started. Also, it's how you access your textbook, and your textbook's obviously going to be really important. That's one more thing I would advise, and that I did in physics, is your textbook is a really important resource. There's other resources, but your textbook is the primary one, and you can solve most of the problems just by going back to your textbook. Everything that's in the problems is going to be explained in your textbook. So if for some reason you don't see it in your textbook, you need to kind of read it over or think about it differently, because it's all there, even the most difficult ones. Now, like I said, that isn't the only resource, but I would say it's the most important. So I think the textbook is kind of good. It's doesn't over-explain things. It's actually pretty concise, and so it doesn't really take a lot of time to read. It'll probably make more sense. I'm going to post video lectures, so after I kind of talk about it, it might make more sense. But that's the most important thing. And the other thing, like I said, you need to get started on your problems as soon as possible. So the way that works is you'll get a code through the bookstore. That's kind of your personal code. and then you'll also have a code for the course, a course code. And the course code is in the first announcement that's posted in the class. So you'll just have to look at that, put in your personal code, and that should pretty much be it. So I want to make sure everyone is logging into the course tomorrow and setting up their WebAssign account. And if it's not set up by the end of tomorrow, I'm going to be emailing you to get it set up, because that's the most important thing to start off with. So yeah, I pretty much covered the other part. So along with the problems and just kind of the general part of the course, I'm going to be posting lectures on the material. Most of the videos I recorded almost 2 years ago, more than a year and a half ago. I found that they worked pretty well. I think maybe I could improve on them a little bit if I did it again, but I think for the most part they work pretty well. I'm going to record some new ones because there was a few weeks there where I didn't record lectures. So I'm going to at least record ones for those, and maybe a few additional ones. But I don't anticipate this term re-recording ones that I've already done. So that is going to be a big part of it, and that's a big part of a physics course or most analytical science courses is the lecture. So yeah, I'll be posting those, and I'll post them on YouTube. Well, actually, the ones that I recorded are already posted on YouTube. So I'll give you that information tomorrow when I post that. And so once you get your WebAssign account set up, you look at the textbook. I would even suggest maybe even looking at the problems ahead of time before you start watching the videos. It's up to you. And then go ahead and watch the lecture videos. The advantage with YouTube is I know that students are using a lot of different devices, and most everyone is going to have a smartphone that so YouTube is really accessible that way, and I know almost everyone is going to be pretty familiar with YouTube as well. There's a few drawbacks, like maybe you get commercials or something like that on it. There is some other ways I could do it, but I find YouTube works the best because it's the most accessible for everyone. And as long as there's not, and since there's not any like term specific or student specific content on there, I make them public instead of private. I can record sessions or something and put them privately, so the public can't actually watch those videos. But yeah, I'm gonna just and they're already up there, so you can go watch them if you want to. So the lectures are one thing. The other thing that I'll do, and I know this isn't, I don't know how common it is at SNU, but I'm gonna do recitation or tutoring session or a help session, basically. I'll try to do that on Thursday night, but I have a lot of stuff going on Thursday night, and I think a lot of other people do too. So I'll probably, either be Thursday or Friday night. Now I understand Friday night, not a lot of people necessarily want to work on their homework and stuff like that. But, I also find a lot of people have kids or they're working, and that works good for me too. And it'll be generally earlier. So yeah, and so that's basically going to be help on your homework problems, or just live explanation. And that's really the best way to teach and to learn is through a live session like that and a dialogue. So you can ask questions and questions upon questions and that kind of thing. I would say most of the time when I've done this at SNU, I don't have very good attendance on that. So we'll work on that. And if, people aren't showing up, then I probably won't. I'll stop doing that just in general. But, that's always going to be available. So if you'd like that, I will do those for the first several weeks. And even if the attendance isn't good, if you want to do it whatever week, then I'll be there to help. And then also another option is a one-on-one session. I'd really encourage people to do that. don't be afraid to ask me. I don't really mind doing that. I really like teaching one-on-one, and like I said, I really like making a connection with the students, with all of you. So the best way to do that is to do a live session, and I use a platform called Zoom. It's been around for a little while. It's on the newer side, but I find it's a lot more commonly known maybe than it was a couple years ago. And I find it works really well, especially as far as cross-platform, either Windows or Mac. Works really good on those. And also Chromebook or a Google platform, which I've noticed is becoming a little bit more common. I guess I haven't actually used it, had a student use it on that yet, but I'm sure it works fine. Really, it just works. You can download it, but you don't have to, and it will open in your browser. So it's easy to do, even on your cell phone or something like that, if you need to do it. Okay, so that's good for the problems. I would say that's probably the most difficult part of this course, and I want to reiterate: get started on the problems early and know what the problems are working on, and it's really important not to get behind. There is a late policy of a 10% penalty for one week, up to 1 week. But after that, there's you need a good some good reason why you weren't able to get it done a week late. But the real problem is if you're a week late and you're working on the problems from the week before, then you're not going to have the time to work on the problems that you should be working on that week. So as the most important thing in this course, I would say, is to not get behind on the problems. Okay, so that's good for the problem set so far. And the other thing is the project, the final project. And this is, like I said, I find a lot of students are not very clear on the instructions and what exactly to do for this project. And I think part of that has to do with just the course design, the way it's set up. And so I'm going to do everything I can as an instructor to explain this the best I can, and even give you some supplemental materials to kind of help you out. So the first thing to do, and this explains it the best, is go into the course material and find the rubric for the final project. Now there are 3 milestones essentially, and there's a few other assignments that you need to do with the project. But that one rubric that explains all the milestones explains it the best. And there'll be 2 components to this final project. The first component is software physics simulation. And this is actually really fun, and I would say probably the most fun part of the course. And I find all the students either find this easy or fun or both. And it's really great to see students find this fun and going above and beyond, because I find that you really can. And it really is great use of creativity and imagination, the type of stuff that you can really do in physics with a project. So the software program that this course uses is called AlgoDo. And so the assignment the first week is just to download it, and then you'll start working with it. I encourage you to work with it as soon as you want to, even just start playing with it. Every so often, few terms or whatever, a student will have some trouble with it, because it is software. It's not really widely used, so there tends to be a few bugs or something in it. I already had one student that got a hold of me that uses a Chromebook, the Google platform, and it's really just for Windows and Mac. So I'm working with that student, and there's things we can do with that. But otherwise, sometimes as you go along, I would say some things that use more processing power, certain elements of it, like flowing water, things like that, and kind of hold it up a little bit. But I find mostly students don't have that much trouble running it on their machines. So yeah, that's the first component of it. And as you'll see, all the stuff that you can do and the different, uh, um, all the different types of physics and objects and motion and dynamics that you can do with it is really fun. And what you'll be doing with that is building a Rube Goldberg machine, and we'll talk about that, what that is, the first week of class. But they're really fun, and I did some when I was in school, actual real ones instead of simulated ones. But yeah, I think that's a good use of it, and like I said, that can be fun. So that's the easiest part of the project. The hard part of the project is you'll have to write papers about what you're doing. So the first week you just download, I'll go do. The second week, you'll do like one interaction, which will just kind of be a start of your project. You'll want many multiple interactions in your Rube Goldberg machine. That's kind of the point of it. So you'll just get started on that the second week. And then the third week, we're going to have a paper due. And one tough thing about that paper, now what it is, it's a qualitative description of your machine. So even though you're just doing one interaction on the first or the second week, you'll want to write a paper of, it's basically going to be 2 to 3 interactions. And the most important thing and the hard part about the way this is designed is you're going to have to describe the energy and momentum. Now it's qualitative and it's not using equations, but we don't go through energy until week 4 and momentum until week 5. And this paper is due at the end of week 3. So as you can tell, common problem with this design of the course is on week 3, you're going to have to write a qualitative description of energy and momentum, except for we won't have covered it yet in the course. So what I'll do is I'll explain that the best that I can. And I think that since it's a qualitative description, I don't think that should be too difficult because you won't have to do the equations and calculations and things, which we'll cover. But that's kind of one hang up, and I want you to be ready for that. So I want you to be aware of you're going to need to know energy and momentum by the end of week 3. I'll be there to help you with it. Yeah, just be aware of that, but that's important to know. So then at the end of week 5, we won't have anything to do for the project on week 4. In week 5, it's going to be a quantitative description, which means that you're going to need to use the equations and calculations and find the values for the energy and the momentum at the end of week 5. And by then we'll have covered energy and momentum. And one thing that's going to be important to do is in your simulation, you're going to have to find the values in the simulation. And I'll show you how to do that. That's pretty simple. Fairly simple to do once you figure out just exactly how to do it, as far as finding it in the software. But once you do that, it's pretty straightforward. Another thing just to throw out there is there's lots of examples online and YouTube videos of it and that kind of thing. I'll do some demonstrations and that type of stuff, but I'm not going to do too much of that, and there's a lot out there. I'm mostly just going to show you where to find the values and stuff like that, and kind of maybe how to get started. Okay, so that's week 5. That's basically going to be the most work for your paper because you're going to have to find all the equations and do the calculations in your paper. And I find that's kind of the toughest part. And these concepts are conceptually difficult. But the thing is I really have a good idea how well people understand it, because if you can write it out and actually do the equations, that shows your understanding even better than being able to solve some of the problems. Because maybe you can find the right equation and plug in the right numbers for an example problem, but for your own simulation, sometimes it's a little bit more difficult. But that's why one reason I really like it. So be prepared on week 5 to put in a lot of time for this paper. And then week 6 is going to be when you turn in your final simulation. So you have till week 6 to do your whole simulation. And I find that's really really enjoyable for me to see what students have done, and I think it's really fun for a lot of people to really build it out. Um, and then in week 7, your final paper is going to be due. And mostly it's going to be correcting mistakes and edits and things for your paper from week 5. So it's not a lot of new stuff. There is one new component that you add at the end that has to do with the electromagnetic spectrum that we cover in week 7 and 8. But mostly it's going to be correcting the stuff from week 5. So the most work is going to be in week 5. So that's all of your final project explained right there. Now I'll be helping you through it. I'll be explaining certain components and stuff again. But if you watch this video, you should be aware of each week what you need to do for this final project, and be planning ahead for it. So that's the problem sets and the project, and the last component is the discussion board. And this is something I think everyone is going to be familiar with, unless this is your first online course. At least first one that's new, but I think most other schools also have the same type of discussion board. So just as far as the discussion board, I do want to mention a few things, especially since we're getting started this first week. Well, the first thing is they're going to be due on Thursday, the first discussion board, and then you're going to write response posts. And I really want everyone to try to make these interesting with real-world examples. Now, they can either be from your career, what you're most interested in, or they can even just be things in your everyday life. Driving a car is a real common one, or all kinds of stuff like that. And I also want you to use as much physics as possible in it. The more physics that you're writing in there is the better. Now, I do want this to be a well-written post with good English, good grammar, good punctuation, that type of thing, and that's important. And, have good complete sentences and paragraphs, but also I want you to put as much physics as you can in it. And your response post, too, should have physics in it instead of just, great post that was interesting. That's not what I want to see. Also, I want, stuff that's going to try to start a good conversation between you and the other students, your fellow students in the class. And I want that discussion to kind of continue. So, it's important to write 2 good responses, but I don't really want you to just stop on that. If people are responding to your original post, I want you to kind of keep a good conversation going on with that. And the ones you respond to, those posts, I want you to keep a good conversation going on that. And also you can, once you get your 2 good responses going, you can also write shorter ones for other people. So I think that's going to be in one of the more interesting parts of the course is just the type of real world examples, and I see a lot of good ones. The other thing with the post is the earlier the better. The earlier you post it, the better it is, because that's going to give other students more time to read your post and respond to it. Now, Thursday is the due date, but I would say really the earlier the better, because if you post it late on Thursday, then it's Friday, Saturday, Sunday, and other students don't necessarily have as much time to read it. Also, it's done earlier in the week, so you don't have to read about it. And what that also does is other students who want to post earlier post responses. If your original post is posted earlier, that gives other students more time earlier in the week to respond to it too. So that's the 3 main components of this course. Like I said, this video is going to be a little bit long because it's covering everything, but I think that's really important. And the last thing are just a few housekeeping things. And so I went over going over these last instead of first, but part of that is because I think they're things most people should know already. So the first one of these is to make sure you have a good internet connection, a good solid machine, whether it's your laptop or whatever. That's important. And I know Now, laptops can break. My laptops have broke, and I know how that works. But so it might actually even be good to have a backup plan if you don't have necessarily the most solid machine at this point. And then also a quiet place to work. I found that's really important, especially for people who have kids. I mean, I have an 11-month-old son right now, and it's pretty much impossible to do work and watch kids at the same time, especially at that age. So I think that's really important one way or another. Make sure you schedule time by yourself or whatever that's quiet to work on this, and that's going to be important. Um, the second thing is as far as life situations, uh, illnesses or loved ones in the hospital or that type of stuff that come up unexpectedly, or also plan stuff like vacations or weddings and stuff like that. Let me know as soon as you can. The sooner the better. Um, if you let me know ahead of time, I'm going to be able to work with you well. If it's an emergency or an unexpected thing, still the sooner the better, and I'll still be able to work with you. But if it's you don't let me know and the work's not done, and you let me know after the fact, then it's going to be more difficult for me to do it, and especially if it's a planned thing. So it doesn't have to be something real long. It doesn't have to have details in it necessarily, but it's really just a fact of letting me know. Um, and then also, yeah, that's important. And I'll definitely work with you. And I know that this is an online course, and it's students are taking this because it allows them to be more flexible, and they have busy schedules and things like that. So I understand, and so it's part of my job to work with you with that type of stuff too. But the sooner the better is better for both of us. Um, then the last thing is something I kind of already talked about, but make sure you don't get behind in this course. And if you're having trouble with the material, let me know and ask for help. Um, like I said, I'm here to help, and I know that it isn't. I honestly don't know what your other courses in SNU are like, and how the instructors are, how open they are to do live video sessions and that type of stuff. But I definitely am. So I don't want you to be apprehensive or nervous or anxious about asking for help, because I am here to help, and I like teaching students. And like I said, that's the best way to make connections with the students. And that's the first thing I said, and I really mean it, is I want to make the best connections with all of you as I can. And asking for help and setting up these sessions is going to be honestly the best way to do it. Um, and I would also just kind of add to that. Most students do fairly well in this course, um, but there's a big difference between students that are having trouble and are asking me for help and are really trying hard, and students who are having trouble and not trying hard and not asking for help. And that makes a big difference, because not only will the students that are having trouble at first, but putting the work in, not only will they understand it better as the course goes along, and I see that all the time. Students that don't necessarily understand it the first couple of weeks, but the time we get to week 5 and 6 are really understanding it well. Um, that's great. But the students who are having trouble that aren't working hard and aren't asking for help usually end up in trouble. And so if you're not asking for help and not, then the course is gonna be a lot more difficult. Let's put it that way. Um, so yeah, that's it. I know this was kind of long, but hopefully it wasn't too long and too boring. And I laid out everything that you would need to know for this course. So I feel good about having that to start off with. Now, I'll review and repeat these things and go over it as we go. But hopefully that gives you a real good overview of what to expect for the course. And I really look forward to meeting everyone either if it's just through the discussion board or being able to do live sessions. And I should say one thing that I don't necessarily expect. If you don't have trouble with the material, I don't necessarily expect you to show up to the live sessions unless, you just want to for some reason, or you want to check out how, even for your like papers and stuff like that. If you get them ahead of time or you have questions about it, I'm going to be there. But if you really don't feel like you need any help, and you're doing great on the problems, and I understand that, this live video interaction and stuff isn't necessarily that important. And I kind of expect, as far as the lectures and some of these videos, just kind of to go out there and not necessarily get a ton of input back. But the more input and stuff I get back, the better. So that's great. I'll hopefully see everyone logged in tomorrow. I'll post the lecture videos, and please email me if you have any questions. That's the best way to get a hold of me, is to email me, and I'll get back to you within 24 hours. Hopefully sooner, especially this first week. And I hope everyone enjoys the course, and I hope we have some fun and interesting discussions, and just generally have an enjoyable experience, learning physics. And it really does underlie so much stuff in this world. So I find once people start learning it, it kind of helps you have a little bit different outlook on the physical world. So glad everyone is here in this course, and I'll talk to you one way or another later. All right, thanks.